Hi everybody. In this lecture we're going to talk about configuring change capture. In this lecture you're going to learn how to perform the following. Perform the procedure to create a classic extract process. Add a local and remote trail files. Start and stop an extract process group. And delete an extract process group. Here is again our roadmap for configuring Oracle Golden Gate. In this lecture, we will cover the third stage, that is, configuring the extract or change capture. As discussed in Golden Gate architecture lecture, the extract process reads committed transactions from the database transaction log file or archive log files. It saves those transactions trail files locally or remotely. An additional extract can be configured called a data pump to send the data from the local trails to remote systems. The data pump process sends the data to one or more target systems. The pump process has the ability to manipulate the data before sending it to the target system. This feature can be used for data transformation if you need to do that. If you have multiple target systems, you can have one pump process sending the data to all the target systems. However, this isn't the recommended configuration because if one of the target systems goes down, the extract may shut down, causing the updates to all targets to stop. You better have multiple pump processes running in the source system. Each pump process is sending the data to a single target system. As I said before, although configuring the pump is technically optional, it is highly recommended to configure it. To configure the extract and pump processes, you do the following procedure for each process. First, you edit the extract parameters. With those parameters, you're telling the extract how to connect to the source database, where to save the trail files, what are the tables that the extract should read from, and the connection information to the remote target system. Secondly, you add the extract process. This is a single simple command that you run in Golden Gate. Thirdly, you add a local trail for the primary extract and a remote trail for the data pump extract. Finally, you start the extract processes. I will cover each of those steps in the incoming slides. To edit the parameter file of any process in Golden Gate, issue the command edit params followed by the group name. This command will create the parameter file for you if there isn't one already, and open the file with the default operating system editor. In Linux systems, GGSCI will use the VI as the default editor. If you want to change it, use the command set editor. The slide is showing an example of a parameter file for a primary replicate process. Let's study its contents. The first line is indicating the type of the process followed by the name of the group name. In this example, the process type is extract, and the group name is EHR1. The second line sets the default of the environment variable Oracle SID. If you don't set it in the parameter file, the operating system value will take effect. You can set any other environment variable if need be, like Oracle Home or NLSLang. The third line is defining the ext trail parameter. This parameter specifies a trail on the local system. Later, we have to create this trail in the GGSCI. If the value as shown in the slide is used in a configuration, Oracle Golden Gate will generate the trail files in the dir.dat subdirectory. The trail name can contain only 2 characters. Oracle Golden Gate appends this name with a 9-digit sequence number whenever a new file is created. In the example in the slide, you see the path of the ext trail parameter. It ends with the characters ES. Those characters are not directory name. Those characters will be used by Golden Gate to generate the trail files. All the trail file names will start with ES and appended with an incremented sequence number. ext trail must precede all the associated table statements. Multiple ext trail statements can be used to define different trails. The user ID parameter is used to define the credential required to connect to the source database. As the password is exposed in the file, this is considered as a security concern. One solution you can use to hide the password is using the wallet. We will cover this topic in a lecture dedicated to security issues. The next parameter configured in our example file is the log all subs calls. When you execute an update statement on a record, the values of the updated columns that were there before the update statement are called the before image record. What this parameter is doing is telling the extract to include the before image of the supplementally logged columns into the trail. By default, those columns are the primary key columns and the scheduling columns. Scheduling columns are the unique index columns and foreign key columns. So, for an update statement, the extract will include the value of the primary key, and if any of the scheduling columns were updated, their before image values will be included as well. This is important for 2 cases. 1. When you set up bidirectional configuration. 2. When you configure parallel replicate processes. I will explain in more details about this in the lectures dedicated to the bidirectional configuration and to the parallel replicate setup. After that, you define the tables that will be replicated. In the example, we are replicating all the tables in the HR schema plus the inventory tables in the sales schema. As you can see in the example, you can use the table parameter more than once. When you use the table parameter, you can define tables, indexes, triggers, and materialized views. To specify a sequence, use the sequence parameter. As we go through the course, you will learn about more parameters that you may include in the extract parameter file. At this stage, those parameters are fair enough to go ahead with our configuration. In most Golden Gate production environments, a data pump process is configured. As is the case with the extract process, you have to create a parameter file and then start the process. The example in the slide is showing you the important parameters that should be included in the data pump parameter file. With the RMT host parameter, which stands for remote host, you define the host name of the remote target system and the port number of its manager process. The TCP buff size and the TCP flash bytes options are optional. They are used to control the network buffer size and the network packets sent by the data pump over the network. They are useful when you have a network with high latency. The example in the slide is demonstrating how to set those options to a size of 1 MB. With the RMT trail parameter, you define the trail files in the target database system. Include the pass-through parameter in the data pump parameter file if you are not going to perform any filtration, data transformation, or user exits in the data pump process. And this is in most cases is the case. Usually you perform the filtration and the transformation in the target database side. However, in some configuration, like the data distribution configuration and data warehousing configuration, sometimes the data pump is used to do the filtration. The target of doing that is to reduce the amount of data that is sent across the network. Pass-through parameter makes the process operate more efficiently because the process knows there will be no processing needed for data filtration or transformation. In the end of the parameter file, you specify the tables that you would like to transfer to the remote target database. As I said earlier, it is a security concern to have the password in the parameter file. One solution to resolve this issue is to use a credential store to maintain encrypted database passwords and user IDs. Another method is to encrypt the password. We will discuss about those solutions in a separate lecture. Use the add extract command to create an extract group. I'm showing in the slide a simple format of using the command. You start with issuing the command add extract, followed by the name of your extract group, followed by a comma. If you are creating a primary extract, use the keyword translog. This keyword means that you instructed the extract to read from the database translog files. If you are creating a data pump extract, use the keyword ext trail source followed by the path of the trail file. After defining the extract source, you add a comma and define the begin time. You can instruct the process to begin immediately, or you can set a specific date and time for it. I will show you now examples of using this command. Before GGSCI accepts the add extract command from you, you must connect to the source database using the db login command, as shown in the slide. The first example creates an extract group called EHR1 that reads from the database transaction log files and starts immediately. By the way, this command doesn't start the extract process, it just creates it. The second example creates a similar extract process that starts on the given date and time. The third example creates a data pump process that reads from the given trail files. As you can see in the examples, you define the source of the extract processes when you create them, but you define their destinations in their parameter files. So far, we have created the parameter file, created the process. Now it's the time to configure the trail files. To create a trail file on the local system to be used by a primary extract process, use the command add xtrail. The syntax format of the command is simple. It is add xtrail followed by the relative or fully qualified path name of the trail, followed by the name of the extract group to which the trail is associated with. You can optionally define the maximum size in megabytes of a file in the trail. The default is 500. To create a trail on a remote system, use the command @rmttrail. The syntax of this command is identical to the add xtrail command. Here are examples of configuring local and remote trail files. Now we have everything configured. It is time to start up the process. The command is simple and easy. It is a start extract followed by the group name, and that's it. You will not know if the start succeeds until you run the info command. You can run the info command with the extract keyword to get information about a specific extract group, or you can use the all keyword to get information about all the processes running by Golden Gate. You should see running as their status if everything goes fine. To stop an extract process, simply use the command stop extract followed by the extract group name, as shown in the slide. To delete an extract, you follow the procedure as shown in the slide. You first log in to the database, stop the extract process using the stop extract command, delete the extract process group, and finally, if the extract process is running in an Oracle Golden Gate database and it is configured to run as an integrated extract, you need to unregister the extract process from that database. I will talk in a separate lecture about configuring the extract process to run in the integrated mode. And that's it for this lecture. You should have learned how to perform the procedure to create a classic extract process, how to add a local and remote trail files, start and stop an extract process group, and delete an extract process group. In the next lecture, I'm going to talk about configuring change delivery. Thank you.